Today we are going to continue our discussion of the geometric optics. So in the previous lecture, we already studied that when the light propagates in the space and interact with the surface, no matter the surface is smooth or rough, they all follow the so-called law of the reflections. And then we studied that how does the image was formed when they interact with a plane mirror or a spherical mirror. Today we are going to follow the discussion and talking about the light tracing and also the refraction of light. So what do we mean by the tracings? Before that, let's try to refresh our memory. First, for the spherical mirror, we define there are two different kind of category. The first one is concave. What is a concave mirror? It is the focal point was in front of the lens, and the C is the center of the curvature. So now let's refresh our memory that when the light interact with the surface of the mirror, at the point of the interactions, no matter how curved it is, they all follow the so-called law of the reflections. And how do you draw the angle? So you have to draw a so-called normal line, which is the dashed line here. So the normal line will be perpendicular to the surface. Now, the angle between the incident light and the normal line is the incident angle. So the reflected light will follow the rule of the law of the reflection. They also will have the theta angle compared with the normal line. So this is reflected light. And because the incoming light is parallel to the axis, so therefore the reflected light, based on the property we discussed before, that will passing through a point, so-called the focal point. So you can see now all the parallel light, no matter where they interact with the curved surface, all the reflected light all point to the same point and gather together. And the focal point is where the image was formed. And then we finally saying that from the C, which is the center of the curvature, to any point along the curved surface, the distance is r, the radius r, which also describes the curvature of the surface. And the relation between the distance r and the distance from the focal point to the lens, which is the focal length, is this. So focal length is 1/2 of the radius. Now, what do I mean by the ray tracing? So let's study for the ray tracing for the concave. So we just give a name, particular name for the procedure I just described. So the incoming light ray, which is parallel to the axis, which is the so-called the P ray, and all the P rays reflects through the focal point, which means all the reflected light of the P ray passing through the F, the focal point. The second ray is the so-called focal ray. What is a focal ray? It is the light passing through the focal point. All the light passing through the focal point, the reflected light will be parallel to the axis. So you can treat them, it is the reverse process for this one, P ray. The third is the center of curvature ray, which is a C ray. What is a C ray? It means that all the points, no matter passing through the C in these directions or in these directions, as long as the light passing through the C, they always be reflected in the same directions. Or I should say parallel to the original direction, but in the opposite directions. So for examples, if you have the light passing through the C, the center of curvature, and hit on the mirror, the reflected light, the direction will also be in the same direction, in the opposite directions. So this is 3 different rays which can help us to draw the image. So I will give you more information. So the second kind of the mirror is a convex. What is a convex? It is the focal point which is beyond the mirror. So this convex surface, once again, if you have an incoming light ray interact with the surface which is parallel to the axis, once again, when they interact with the curve, the surface, they always follow the law of the reflection. So you have to draw a normal line which is perpendicular to the surface. And the normal line, the dashed line, will passing through the center of curvature. And you will see that in that case, the reflected light will also follow the law of the reflection, and it will follow this way. However, the reason we try to distinguish the concave and convex is that because for the convex, the focal point is behind the mirror. So how did you find it? Then you have to trace the reflected light backward along the dashed line here, and you will find out that as long as the original direction of the incident light is parallel to the axis, then once again, all the reflected light, when you trace them backward, they all gather at the same point, which is a focal point. And finally, once again, the distance from the center of the curvature to the lens is the r. And the relation between the r and the focal length is the same as before. F is equal to 1/2 of r. So now, the ray tracing for the convex will be very similar to what we just defined before. So you have a P ray which is parallel to the axis. So they interact with the surface, and all the P ray, the reflected light, they will follow the direction that extends back to the focal point here. So all the reflected light, when you trace them backward, they all pass to the focal point for the P ray. And the F ray, the focal ray, which is the opposite process for the P ray. The light origin coming in the direction and interact with the curved surface. And if you draw the dashed line, you can assume that they were passing through the focal point. And this F ray will always be reflected to the direction parallel to the axis. So this is F ray. And once again, the C ray is always the ray hit on the curve, and they can trace them directly to the point C. So in that case, if C ray is hitting on the curve of surface in this direction, the reflected light will be parallel but in opposite directions. So this is the ray tracing for the convex. So once again, when you try to draw the image formed by the concave and convex, you need to use the property of the ray, these three rays, very carefully. So now let me give you the examples for convex. When you try to form an image for the convex, you can use the three rays I just defined to show you how the image was formed. So let's try to do it step by step. So this is the object, and let's just focus on one point. It is the top of the arrow. So the top arrow will emit a P ray first, and we know that P ray is parallel to the axis. So the reflected light, when you trace them backward, they will passing through the focal length. So far so good. So this is the first one. Now let's use the F ray, which is the ray will passing through the focal length. And in that case, we know that the direction of the reflected F ray is parallel to the axis. So you can trace them backward again. So the green dashed line will intersect with the purple dashed line. Now, it is almost enough, but let's try to draw one more ray and we can form the image successfully. So this is a C ray. So there's a light emitted out from the top of the arrow, and it is a C ray, which means the dashed line will passing through the curvature of the surface. And if you trace them backward, you will find out now there are three lines and intersect at one point. So this is actually the top of the image. So you can do that for all the points along the arrows, but you don't have to do that. Once you find out the top of the image, then you can basically draw the image is here. So you can see that for the convex mirrors, the image was formed after the mirror, and the size is smaller than original size, but it is still upright. So let's try to study a little bit in a little bit different case. So you have the object now which is closer to the mirror. You will find out the image form is still behind the mirror, and the size is still smaller than original size, but it is upright. But you will find out it becomes bigger when you compare with the original image form. So when the object getting closer, the image form will be closer to the mirror and also become bigger. But still, it is smaller than the original size. But if you try to move the object a little bit away from the mirrors, so you try to move away from the mirror, then not a surprise to you, you're still going to form the image behind the mirror, but now the image will getting smaller. So to conclude that is, the image form for the convex mirror, they are always behind the mirror, and the size is always smaller than the original size, but the image is upright. So now let's take a look about the ray tracing for the concave mirrors. For the concave mirrors, you're still using the free rays we just used before, but now you have the object here,